Okay. Did I answer all your questions?
You did, thank you.
Yeah, okay. If you have any more, I don't technically have office hours tomorrow, but if you drop me an email or a discussion board, I can always help out or get together with you quick for a few minutes.
I appreciate that, thank you.
Okay. All right, well, I was waiting for Yesenia, but I think we'll make a start, and hopefully she'll be here in a minute. Okay, so tonight, this afternoon, we're going to take a brief look at some of that statistical verbiage that you've been coming across, try to help give you an idea of what you're looking for, because unless you take a couple of, actual grad level statistics, that data analysis and results section can be a little overwhelming sometimes, and you don't even understand the language well enough to know what it is they're saying. Okay, so I'm not going to delve in really deep because this isn't a stats class, but hopefully I've got enough here that it will just make the next few weeks of reading research a little more comfortable for you. Okay, so the first couple of slides really are review. We've talked about this information before. The first thing that any researcher has to do is decide what the question they have is, right? And so that's the process that you guys are in right now. What is my question? And at the master's level, we want to try and keep that as simple as possible. One independent variable, one dependent variable, okay? And then, once we've decided what it is we want to know, then we can make the decision about whether or not the study is going to be quantitative, qualitative, or possibly a mixed methods and use both, right? So I'm going to concentrate, because I know very little about qualitative, and I've put information up on Blackboard for you when we watch Dr. Berkey's qualitative lecture. There's info there. I'm going to concentrate on the quantitative side because that's the only bit I know anything about. So it would not be much help to talk to you about qualitative. So we want to think about, when I'm collecting the data, what do I have? So what level of data am I collecting? There's always descriptive data. So these days we don't have to do hand-calculated statistics, thank goodness. You can get a software package. The one I used in grad school was SPSS, but there are several different types of software package, but they all do the same thing. You put the numbers in, you press a button and tell it which statistical analysis you want it to run. It does all the jiggery-pokery and spews out a load of tables with numbers that then you can interpret. Okay? So we always get descriptive data, and then we're often looking for either differences between items or relationships between items. So when we do quantitative, typically that's what we're looking for. And we want to be able to classify those variables. So on Blackboard, I have given you a cheat sheet that I got from my statistics faculty member in grad school at Auburn, Dr. Guarino. And so I'm going to show you that, but it's up on Blackboard. It is a lifesaver, let me tell you that. Unless you love maths and statistics, this thing is a lifesaver. So, share application. That one. Can you come up for me? Yes. Good. Okay. All right. So, what this cheat sheet allows you to do is to not understand statistics and still get the right statistical analysis, which is very, very helpful. Okay? So, the first thing that you want to do is decide how many independent variables and dependent variables you have. And as I said, in your studies, we're looking for only, particularly only one dependent variable. So we're going to do a univariate analysis if you carry on to write a thesis. All right? Then what you want to do is make up your mind whether or not your independent variable is continuous or categorical. And if it's categorical, it could be dichotomous. So that would be like sex is dichotomous, right? Males, females. But time would be continuous, okay? Athlete teams would be categorical, because we've got 5 or 6 of them, okay? So you define your independent variable, and then you define your dependent variable exactly the same way, and then you use the cheat sheet, right? So if your independent variable is dichotomous, and your dependent variable is continuous, the correct statistical analysis to use would be a t-test, right? Now, you might have a dichotomous, you might have 2 lots of dichotomous independent variables, in which case you would probably run an ANOVA, okay? But this sheet takes all the decision away from you, right? You don't have to understand. And it's also, I think, a useful tool when you're starting to read research. If you have a paper that isn't too complicated, to try to do the same definitions for yourself on the variables in the paper, and then see if they've used the statistical test you would expect from the cheat sheet. Because that way you're manipulating the information for yourself a little bit, and it will help you understand how to use this cheat sheet a bit better. Does that make sense?
I think so.
We love stats. It's always a little confusing. It's always a little confusing. Now, then you also want to look at table 24.1 in the textbook, not the APA manual. And that's on page 324. So they're also looking at the level of data. Is it nominal? So does it just have numerical data that doesn't necessarily have a meaning, right? So speed on 100 meters, right? But if the data is nominal, so it's 0 or 1, but 0 means no and 1 means yes, or 0 means boys and 1 means girls, right? Then that's called ordinal data, okay? And then we also can have interval data or ratio data. So again, what I would suggest is don't try to learn it, right? Because in our program, sadly, we don't have a stats class on the degree plan. We all would like one. It's just we get told off by the senior administration every time we try to add credits to a degree plan. And so the only way we're allowed to add statistics is to take out something else. And there isn't anything on the degree plan that we don't feel as a faculty you need. So we have this dilemma where you really don't get enough statistical background in the program, which is disappointing, but our hands are a little bit tied with that. So what I would suggest is just don't try to learn it, but use your textbooks a lot, right? So as you're reading the article, come back if they use, oh, not again. Ay, ay, ay. Oh, this is going to be fun. What the heck? It's not even giving me, usually it gives me a little message and a little circle that says I'm disconnected and reconnect. No, it's just kicking me out completely. So I have no idea what's going on there. Yeah, so where was I? Yes, so if you're reading a paper and you see one of these words, don't try to read the paper without going back and checking what the word is. Don't try to remember it, because that's asking too much of yourself. And if you don't go back and check what the word means, reading the data analysis and the results section becomes really hard work, right? So the more you can understand that very particular type of verbiage that is used in those sections, the easier it becomes to read them. Okay? Oh, okay, and then I put up another sheet for you. Let me see if I can do that from here so I don't have to keep running backwards and forwards. There it is. Yay. Okay. Can you see this? It says Appendix A.
Yes.
Okay. So this is from a different textbook than the one that you guys have, but I really like this appendix because they list the names of the statistical analyses on the left here, and then they tell you when that is typically used and why. So again, it's kind of a cheat sheet. You can go, oh, they're doing a multiple regression. What the hell is a multiple regression? And you can look it up here and get a very, very simplified definition and explanation of a multiple regression. And then you don't have to go digging into complicated statistical textbooks. Right? So I think that the cheat sheet and this table will make reading those results sections in particular a lot less painful, hopefully. That's the plan anyway. Okay? Let's get rid of that, come back to you guys. Okay, shape of the data. And they do talk about this in around the area where that table 24.1 is. They also talk about the shape of the data, but I'm going to draw some squiggles for you. Okay. So let me back up a little bit and talk about shape of the data. That means that if you plotted your data, right, bearing in mind that if you're doing a quantitative study, that data is likely to be numerical. Okay? So none of this stuff applies if you're doing qualitative, where the data you're getting is verbal. Right? So if you plot your data, what does it look like on the graph? And you can do that using a bar chart or just a line. Sometimes, most of us don't bother. Depends how much you love statistics. So, okay, we're going to look at what a bell curve and skewness and kurtosis look like on a plot, because then that will help you interpret when you see those words, what the authors are telling you, okay? And it's going to be a bit squiggly because it's a little hard to draw. But first we're going to do a bell curve. Okay, so a bell curve, assume a XY axis, okay? A bell curve means that your data is well balanced, right? So we would say that's normative. I've got, if this is average, I've got the same number of people that are below average, the same number of people that are above average. I've got very few people who are absolutely dreadful. I've got very few people who are amazingly brilliant. Right? So a bell curve's pretty straightforward. Then what we get, and you see this a lot in exercise science papers, we get skewness. So skewness can be negative or positive, all right? So what that means is, if my data, when I plot it, I have to go back to a pencil. If my data, instead of looking like this bell shape, looks like this, okay, then that is called negative skewness. And it took me forever in grad school to understand why this wasn't positive, right? So I have a little cheat, because when I looked at this, I was like, no, that has to be positive because all the data's in the positive, right? Now, it depends which way the tail is pointing. So if you put a little arrow here, the arrow is pointing negative on the x-axis, right? So this is negative skewness. So what this tells us is that if this is halfway, what we have is a large amount of our test population above midpoint, right? And too many people doing poorly, okay? You can also have positive skewness, and that just looks the flip side. So positive skewness goes that way. All right? So sometimes when you're reading the results, they'll say the data was skewed. This is what they're talking about. It means that the population was not normative, right? Then the other terminology, and I have to say, I understand what it means, and I've read, I mean, not recently, sadly, but over the course of time, I've read a lot of research papers. I don't think I've seen this particular term more than once or twice in all the papers I've ever read. So the last one is kurtosis. And it's either more or less peaked. So that means that here's our bell curve. What happens is, come on. Our bell curve does that. Or our bell curve does that. Okay? But as I said, I rarely come across authors using the description that their data has a kurtosis peak. But you do see the data was skewed quite a lot. So I think that one's important to be able to visualize because it will give you a good idea of what they're trying to tell you. Does that help? A little bit?
It does, because I've seen a few of those.
Right.
Didn't understand it.
Yeah, it does pop up in our kind of research. I think sometimes because we can't always use, remember way back at the beginning when we were talking about the sample population that you pick, and we were saying that in PE and movement literature, we often have to just take what we can get. We don't get the opportunity to have a real true random sample. We have a convenient sample. And so what I think happens is when you have a convenient sample, you're more likely to get this skewness because everybody's coming from a reasonably similar experience, right?
Right.
Okay. All right, again, it's really about the terminology, just to give you an idea so that then you can go look it up rather than just go, oh, I don't know what that word means and keep going, right? Because then nothing makes sense, okay? So you'll see the terms parametric and non-parametric tests. So the test means the analysis, the statistical test that is being run on the data. So I can choose a parametric analysis or I can choose a non-parametric analysis. When do I do that, right? So if I use parametric analysis, then that means that I have pretty clear interval data, right? So the differences between the blocks of sample population are relatively equal. And I've got this nice normal bell distribution, okay? If I don't have a normal distribution, so if when you're reading an article, this would be a big no-no, right? If when you're reading the article, they tell you the data is skewed, and then they tell you they used a parametric test, that's wrong. You can just throw that in the bin, right? Because if the data is skewed, if it's not interval or it's not normally distributed, you have to use a non-parametric test. Or you have to do a pre-test on the data before you can do a parametric test. Okay? So again, I wouldn't spend a lot of time really understanding. I couldn't tell you very much more than I've told you, to be honest. And I took a lot of stats classes. But they were a very long time ago, and I'm old now. Yeah, you don't, it's not that you need to understand necessarily, it's that you want to recognize the term, so that maybe then you can go look it up and just double check. If you need to, right? You might not need to. It may be perfectly clear what the authors are talking about. Some authors do an absolutely brilliant job making their results section user-friendly, and other authors seem to go out of their way to make it Martian. And then you just go, poof! Right? Because it can get very ugly sometimes. All right, and then there's another table on page 327, table 24.2, that again is giving you appropriate tests for particular levels of data. So there's lots of information in the textbook and on Blackboard to help you navigate through these results sections that you're going to be reading, so that maybe you can get a little bit more out of them and they're a bit more enjoyable. Okay. Any questions up to there? Because I'm going to change tack a little bit.
I don't have any questions. I think this explains a lot, though.
Good, good.
I have none, thank you.
Okay. Well, I have a question for you, though. So one of the comments that I got last semester was that it would have been helpful to have the statistical data earlier in the semester. And I really, really thought hard about that. But I wasn't sure you'd done enough reading at that point for this to be beneficial. Does that?
I think maybe for like the last article summary, maybe to go into detail about this, I think that would have helped. Because, you know, at the beginning, we were still kind of learning about it and still pretty confused. But
Yeah.
I think the last one would have really helped me.
Okay, so try to slip it in maybe before the final summary paper.
Yes, that would be
Okay.
my opinion.
Okay.
I would agree with that. I think I would have been on overload if I would have gotten it much earlier than that.
Yeah, that's
Oh,
what
yeah.
I was worried about, was that, you know, there's so much stuff going on at the beginning. If I throw statistics into the mix, everyone will quit. Okay, I'll think about that as I'm setting up the syllabus for spring then, because it wasn't that I ignored the comment from last semester, I just wasn't sure how to use it. I was like, I don't know what to do. Okay. All right. So you will often not only see a purpose statement, but you'll also see a hypothesis. Okay? Not every time. Sometimes it will depend on the journal that you're looking at. Some journals are more picky about you stating your hypothesis as well. So you don't always see it, but if you do, then this will help you understand what they're talking about. So the research hypothesis sometimes is labeled H1, and the research hypothesis is what I think might happen when I run this study. You have to come up with the hypothesis ahead of time. It's a bit like alpha. You're not allowed to run the study, look at the data, and then go, oh, I think I'm going to set alpha at, right? Same with the hypothesis. So the difference or relationship between the participants will be significant. So let me give you an example. I'm going to use my kind of data because that makes it easier for me to explain. If I go into a new childcare centre and I test the children's motor skill competence, and then I run my motor skill play intervention, and then I retest the children's motor competence, what I think is going to happen is that there'll be a significant improvement in their motor skills from pre to post. Okay? So my research hypothesis would be that there will be a significant improvement in motor skill competence. Right? There's always the flip side to that. And it becomes important to understand this when we look at the next piece of information. Okay? So the flip side of the research hypothesis is called the null hypothesis. The null hypothesis is often labeled H0. And the null hypothesis means there's no difference. Right? So if my research hypothesis is there will be a significant improvement in children's motor skill competence, my null hypothesis is there will be no difference in children's motor skill competence pre to post test. Right? Obviously not the thing we want to find. Okay? So, as the researcher, we go in wanting to reject the null hypothesis. I don't want the null hypothesis to be right. Right? That would be disappointing. And we want to be able to accept the research hypothesis. Okay? I want to be able to say, yes, there was a significant difference. Okay? So, building on that then, let me just check the camera a minute, make sure this is still running. Yay! Okay. So, that research and null hypothesis play a role in what level we set alpha at. Okay, and alpha is the probability of rejecting or accepting the null hypothesis. Okay, a priori means we have to do that ahead of time. So that is research etiquette. I have known people get published breaking that rule, which is very disappointing, right? Because what they did was they set their alpha level, they ran their study and their stats, they didn't find significance, but if they change their alpha level, they do find significance, and then they send it off to get published. That's cheating. Right? That's really, really bad behavior. And if anyone had known, that paper would have got thrown out. Right? So the rule is you pick alpha, your P level, ahead of time. Right? So we want to make our alpha as small as possible so that if we find significance, we can reject that null hypothesis. Okay, this gets a little bit complicated. Don't worry too much about it. It will make more sense as you read more. Okay? So, if P is greater than alpha, so let's say I set alpha at 0.01. If P comes in at 0.015, I'm stuffed, right? That means I have to accept the null hypothesis, that there was no difference between whatever it was I was looking at, okay? However, if P is less than or equal to whatever value I set alpha at. Then I can reject the null hypothesis. There is a difference. Yay! We all like that. Okay? Actually, failing to reject the null hypothesis can also be an interesting result and worthwhile publishing or presenting at conference. Because if we find out that what we did didn't work, that may be just as beneficial, because now we don't have to, it's kind of like the conversation, Christine, that you and I had earlier today, right?
Yes.
If I can find out what doesn't work, I don't have to waste my time on it, right?
Right.
So it's a bit of a blow to your ego in particular. You know, when you press that button on the software, you're like, please, 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 please. Okay. I mean, it's the most terrifying moment, because you've done all this work and you're just like, oh my God, please, 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 please. And if P is large, it's like, no. And it takes a while to get to the point where you can go, okay, this isn't so bad. It's important to know that this doesn't work, right? But it hurts. Okay? So here's what alpha means, okay, when you're reading this, okay? If I set alpha at 0.05, which is typical for exercise science papers, okay, that means that there is a 95% probability that the difference, if I find one, is real and not lucky, right? So if P is less than or equal to 0.05, I found something that really exists. Okay? Now, let me talk you through a different scenario, because it depends what kind of research you're looking at. Okay? If I'm a drug manufacturer, right? And I'm running drug tests, and I need to know whether or not the drug is probably safe, okay? Then we set alpha at 0.01, or possibly even lower, 0.001. That would be pretty extreme, right? But here's the thing. If I set it at 0.01, right, that means there's a 99% probability that the drug is safe. Right? We've still got a 1% chance that the result of the research is wrong and the drug is going to kill people. So that's why sometimes they go even lower. Right? But in our kind of work, we don't need that level of probability, right? I'm not going to kill someone unless they have an underlying health issue, right? Which is a different ball game. If I do my job properly, I'm not going to kill someone in a movement context. So 0.05, 95% probability is just fine. Okay? When you read some psychological studies, they'll set alpha at 0.1. That means there's a 90% chance that when they tell you that this technique is going to work, it might work, right? There's a 10% chance it won't work. That's a pretty big, right? Does that make sense? Okay? sometimes something really amazing happens and you set your alpha at 0.05, right? And you run your intervention with the children, and then you run the statistics, and blow me down, there's a 0.01 on the spreadsheet that comes out. And then you're like, whoa! Right? Because that means that it was way more successful than you were banking on it being. Right? So that's really exciting when that happens. You can tell I'm a bit of a geek about research, sorry. I really am. It's flipping fascinating. Which is why I'm the one teaching this class. Okay. So, type 1 and type 2 errors also come back to this idea of the null hypothesis. And again, to be completely honest, it probably took me 3 years in grad school before I got this right. Okay? So again, don't try to learn them right now. Write them down on a card and keep the card inside your textbook or inside your APA manual so that you can refer to it all the time. Okay? A type 1 error means that we reject the null hypothesis when actually the null hypothesis was correct. Right? So my null hypothesis was there would not be any difference in the children's motor skills from point A to point B. So a type 1 error would be, I'm rejecting that. There is a difference. When actually, there isn't a difference. Okay? A type 2 error means you accept the null hypothesis when actually it isn't correct. So the type 2 error would be, okay, I accept the fact that the intervention didn't create any difference in the children's motor skill competence, when actually it did. Okay? Type 2, if you're going to make an error, type 2 is the preferable error to make. And here's why. We go back to the drug idea, right? Let's say my research hypothesis is this drug will significantly improve coronary artery disease. So my null hypothesis is this drug will not significantly improve coronary artery disease. Okay? So, if I make a type 1 error and I reject the null hypothesis, that means I market that drug as significantly improving coronary artery disease. And it doesn't. Which could kill people. Right? The type 2 error would be, okay, the drug doesn't work. It doesn't do what we wanted it to do. When actually, if they had done further testing, it would have done what they wanted it to do. Right? Is the type 2 error a bummer? Yes. Right? Because it means that you're going to throw something away, maybe, that would have actually worked. But you don't kill anyone that way. Right? If you make the type 1 error, you could kill someone. Not in our game, typically. Right? But that's why it's important to look out for that terminology, because again, they're trying to tell you something quite specific about what they thought was going to happen and what actually happened. And some of the analysis that they do sometimes, you'll see statements like, we ran a XYZ to be certain sure that we had not made a type 2 error. Right? You'll also see the term power quite often, and power is the probability of not making that type 2 error. So I've got so much power in my data that the possibility of a type 2 error occurring is insignificant. All right? So what we want to do often is increase the power and decrease that probability of making a type 2 error. Sometimes you can increase power by having a larger sample size. All right? So if you run your study on 10 people and you almost get significance, your P is almost equal to alpha, but not quite. If you ran it with 50 people, you might find significance. Right? Again, sometimes when you're reading these sections, the author will tell you that they ran XY analysis ahead of time to find out how many people they needed to make power. So you can do that if you've got that option. Like when I do my stuff, I never run that analysis because it makes no difference. I've got the number of children that attend the childcare. I can't magic more children into the childcare. So I don't bother with that pre-analysis because it doesn't make any difference to me. But if I'm sending out surveys, right, and I want to know how many surveys do I need to make power, then it can be helpful to run that analysis ahead of time. Not you and I, obviously. You go over to the math department and you get the statistical specialist to run the analysis for you, right? Because I can't do that, right? So that's why we have stats people on campus, all right? Okay, then the last piece of information. Can you take one more piece of, have I blown up your brain yet? Can you
It's on overload.
You're on overload. All right. So, a really, really good paper won't just talk about P and significance. It will also talk about effect size. Okay? The effect size is often the Cohen's D or Cohen's F. It can be eta squared, which is similar to R squared. Don't worry, you'll see these terms. You don't have to understand them, just be able to read them. Right? The effect size, if it's less than 0.2, is small. If it's about 0.5, it's considered medium. And if it's greater than 0.8, it's considered large. Now, why is this important? Here's the thing, right? I can find significance mathematically, statistically, in a variable that is completely useless to me as a teacher or a coach, right? What's the effect size is more important, right? Is it usefully effective? Okay? So if it's a really good paper and the authors are honest and know what they're doing, and the study is strong, right? They will report both the P, the significance, and the effect size. Okay? What sometimes happens is you run a study and it's a little bit wobbly, it's not very strong, it's a bit of a weak study really, but we're under a lot of pressure to publish and present. Like, I haven't done anything for 3 years and I've got a ton of bricks coming down on me at the moment, right? So that's just the life of academia. So I've got this ghastly study, which if I could go back in time, I wouldn't run it that way at all. I'd do something different, but it's too late because I've already done it and spent all this time on it. And now I've got to get it published. I sort of just forget about the effect size and we just report significance, right? It wouldn't get into one of the really, really, really strong journals, but there are plenty of other journals out there that aren't, you know, that are acceptable, they're peer-reviewed, but they're not the star, right? And I can get published in there and chuck it on my CV and everyone will shut up and leave me alone. Right? So just, you know, what I'm trying to do is just give you some tools to tease apart the studies that you're reading. That term power that I mentioned also relates to the ability to detect an effect size. Right? So the more power I have, the stronger the effect size should be. If one exists, right? It might not. You might have this amazing significance and your effect size is 0.1. Okay, enough blowing up of brains. Any questions? I think, is Ryan still there? Did we lose Ryan?
Nope, I'm here.
Oh, good. Okay. There we go. Any questions?
Not at this moment.
No, it's a lot to take in. As I said, don't try to learn it. I think the idea is if you can recognize the terminology in the paper, then you can go and look it up and remind yourself what it meant. And then the results verbiage might make more sense to you. Right? I mean, that's the starting point. I remember when I first went to grad school, and I hadn't been in school for 20 years, and they're like chucking all these research papers, and I'm like, oh my God, I'm just going to ignore the results section. I'm going to read the methodology and the discussion and hope I can get away without having any clue what that is, right? I did that for at least a year and a half. Because it's complicated, it's a big learning curve, right? So be kind to yourselves, don't expect to just walk away and go, oh yeah, I can read the results section and completely understand what they're saying. It takes tons and tons of practice. It's just like throwing a baseball, right? It takes practice. It's just a new skill, and they all take practice. That law holds true regardless of which skill it is.
Right.
Okay? So, yeah. Anything I can explain further, or?
I think this is just going to help reading it more, though. I'm going to know more of what I'm reading. I appreciate this.
Yeah. Just let it soak in. As I said, just let it soak in. The more you read, the more it will start to make sense.
Right.
You know, that's just the reality of it. Now, if you're reading a qualitative paper, you're on your own, because I have no idea about themes, grounded theory, and all this. I kind of, I've heard that term before, but I don't know what it means. So, yeah. I think I did put up a chapter on qualitative data analysis earlier in the semester. So there is information available for you. There's also quite a bit in the book about different qualitative analysis techniques. So the information is there. I'm just not going to waste your time telling you anything about it. Okay? Next week then will be our last class, per se. And we will look at synthesizing. So when you've got these article summaries, how do you build that in to a paper that you're writing, right? And that's, again, more than anything else, it's practice, but I'll give you a few hints and tips next week. And then we've got a couple of weeks where I'll be in the classroom, but I'll be at home, so that if you've got questions or you want to meet with me about your ANOBIB or about your presentation for the end of the semester, then I'll be available. But they're just kind of there for you to have some space to think and work.
Okay.
Okay? All right. Okay. What is it? 5:30. It's time for a glass of wine, people.
It's 6:30 over here.
Oh, well, it's definitely time for a glass of wine. Here you go. All right. Well, you be careful. Texas
Yes, ma'am.
Texas is doing even worse than we are, I think. Although I don't know. I was listening to the governor's update this afternoon. That was quite depressing, I have to say.
I think we're fixing to get shut down again.
Yeah, I think she's threatening that she's going to have to do that if we don't start behaving ourselves and wearing our masks and staying at home.
Yes. Here in Lubbock, we had 330 cases yesterday and today. So.
El Paso, she said, El Paso today had 748 cases in one day. She's like, do not go to El Paso.
Oh my gosh. It's just stay away.
Yeah, really. 748 cases in one day. Shit, it's insane. And I walked into the glass shop yesterday, so I broke a picture frame and I took it in, and it's, you know, the little lobby area is about the size of the screen here. It's tiny. And I walk in and there's this idiot young man, must have been about 21, 22, tall, lanky, great big wad of chew in his mouth, no mask, chattering away to it. I'm like, I'm backed up against the wall and the door as far away from him as I can get, you know. Like, really?
Oh man.
What does it take, people?
I don't know.
Wear the damn mask. No one likes it. Everybody needs to do it. Get over it.
Exactly.
Anyway.
Nobody likes wearing shoes, but we have to.
I occasionally don't. Okay. Well, have a lovely evening, and give me a yell if you've got any questions. If you need an extension on ANOBIB is due Monday, I believe. If anything comes up over the weekend and you need an extension, just drop me an email, let me know. That's not a problem. You know, things happen. COVID, hopefully not for anybody.
Hopefully not.
But yeah, I have got some students that have it at the moment, so it's around. Okay. Have a lovely evening.
Thank you.
Bye.
Thank you, everyone. Bye.